Welcome to the Networks and Interconnect channel. I'm Chris Davison, and I'm putting together a year-round program of original, always-on content, exploring how networking is evolving to cope with exponential data growth both inside and outside the data center. In this broadcast, Network Transformation, we will cover the latest trends and developments in routers, switches, cabling, and management software technologies. Here's a schedule of other broadcasts and publishing activities we've got planned on this channel for the rest of the year. We're going to be looking at what's happening in the subsea cable market and the latest in network and interconnect innovations. We've got some editorial supplements planned too, and of course, our news desk will be reporting regularly on market activity. And there are lots more channels you can subscribe to. They've all got broadcasts planned across the year, with many of the industry's leading subject matter experts already participating. You can subscribe to all these channels online at datacenterdynamics.com, where you'll also find the latest news, editorial features, white papers, and industry opinions. You'll find our broadcast library here too, with hundreds of hours of on-demand content. Now, we use the On24 content platform to deliver all our broadcasts, so let me show you around it. Here are the speaker bios, here's where the slide deck will appear, and here's the media player. Most of our broadcasts use videos, all of them have sound of course, and you can adjust the volume here or mute the sound. Here's the resource section with relevant downloads and links, and if you've got a question, here's the Q&A widget. Our moderators will try to get an answer during the broadcast, but if they can't fit it in, your question will be forwarded to the speaker to get back to you offline. Some episodes will lead straight into a roundtable discussion. Here's where the link will be, and this is a great opportunity to share your own ideas and opinions. And for our partner-led episodes, you can even book a meeting through the platform here. And finally, if you've got 2 minutes, we'd love it if you could take part in our channel survey. Here's the link, and that helps us with future programming. Now, with that out of the way, let's get started.
So, to our first session of the day, I'd like to introduce Robert Reed to the virtual stage. Robert currently defines product development direction for Panduit's data center fiber optic product line. He's been active in fiber optics as well as photonics industry for over 35 years. Today, Robert will be joining us to discuss the evolution of high-speed multimode optics and cabling from the IEEE short-reach roadmap for the 40 gig, 100, 400 gig to progress in well over 100 to 200 gig single wavelength optics. So with that, please get in your questions, but right now, over to you, Robert. Let's get started.
Hello, I'm Robert Reed, a strategy manager with Panduit Data Center team, and today I'm going to talk about multimode optics and cabling for switch to server applications, focusing on the roadmap to 400 gig and beyond, 800 gig and 1.6 tera. In terms of 400G customer dynamics, a lot of cloud, edge, multi-tenant data centers, and this is going back a couple of years, are starting to look towards 400G short-reach multimode solutions, in particular SR8. We'll talk about that. And what's driving this is the move towards 50 gig network interface cards at the server and eventually 100 gig network interface cards. So people are looking at the multi-mode solutions that are out there and the lower cost single mode solutions. The two protagonists for multi-mode, SR8 16 fiber 400G, 400G BiDi, SR 4.2 which is coming, and DR4 which is an 8 fiber single mode solution. So these are in the mix. So people are looking at these for short reach. One of the things that people have used is active optical cables. I would say that for this very high density breakout application as we go towards 50G and 100G at the server, I think those are non-starters because of cable management issues and known good infant mortality issues with AOCs. So there's a lot of issues there around those concerns, and going back to LC patch cords at the server, that's a desired outcome. In terms of the market evolution as we march towards 400G, and this is a little bit dated here, but I think it's fairly accurate. We're seeing the ascension of 400G solutions in all forms: single mode, multi-mode, multi-lane, multi-wavelength. 40G is disappearing, 100G still rising. 400G, the first application for 400G, like 40G, is a breakout. And varieties of breakout in terms of 4x25, 4x10. So the main breakout we're going to see here for 400G, and the main use case initially is as a 4x100 breakout, 4 ports of 100. That will be for DR4, breaking out to 100G, and the BiDi 400G breaking out to 100G, and also this 8x50G at the server. I think that's an important breakout for switch to server. And there are some applications, legacy support, where people want to break out to 2 100Gs or eventually 2 200Gs. In terms of the evolution of the serial line rate, I plotted out from 2000 to 2030 several PMDs, physical media dependent transceiver speeds. And this is actually the SerDes speed, the serializer, deserializer speed. It seems like not that long ago, but 10 gig is actually getting fairly old. We're moving towards an IEEE 802.3CK of a SerDes, a serializer, deserializer in the transceiver in the PMD, that allows for 2 fiber communications, single transmit and single receive, which is very customer friendly and highly desired. So the driving force behind what I'm going to talk about today is 100 gig single lambda. And it's happened fairly quickly on the single mode side. In fact, there are 100 gig 2 fiber solutions, FR solutions at 500 meters and 2 kilometers. The multi-mode solution is a little bit behind, but it will come out. And what they're looking for there, I've drawn out some of the parameters for this holy cup that the Ethernet Alliance is putting out there, because this is kind of the holy grail, a 2 fiber LC-based solution or a CS connector-based solution that's very customer-friendly, and it provides receive and transmit over a single fiber pair at 100 gig line rate. In terms of the multimode PMDs that IEEE has released, and sorry for this, is a little bit of an eye diagram, but just to level set, on the vertical axis I have the number of lanes, and on the horizontal axis I have the lane rate and the encoding style. So focusing on the number of lanes, and a lane is defined as a physical lane, in this scenario here. So that's 16 lanes would be 32 fibers. And that was the first standard for 400 gig that was ratified, SR16. Kind of gone the way of the dodo bird. And what we've evolved to is, in terms of multimode, is an 8-lane solution. And that was released at least by one OEM maybe 2 years ago. And the 400G based SR4.2, that's a 4-lane solution. So these are really the only protagonists on the multimode side for 400 gig with multimode fiber. And that SR8 solution is really not, although some people will use it in switch to switch, it's really not a switch to switch solution. The 4.2, this is a BiDi solution, an 8 fiber solution, 4 lanes, and that's coming soon. I've heard the middle of this year, early Q2 into possibly the start of Q3. But that is a fabric interconnect solution. So that is really a solution that is for switch to switch. I'm going to focus on the top one, which is the novel solution for switch to server today. This is the single slide I've dedicated towards explaining multimode BiDi, and this is another short reach solution, 100-meter reach solution with multimode. And again, the main use case for this, and it's a little bit of an eye diagram here, but it's a very familiar interface because it's the same interface that we're familiar with for 40 gig SR4, 100 gig SR4. It's a base 8 fiber solution. So with SR4, you have 4 transmit and 4 receive. In this case here, it is 8 transmit, 8 receive, 50 gig each way over each fiber. But the good news for customers is that if you're doing breakout with SR4 multimode today, it's the same cabling rules. The same breakouts that you would use for an SR4 to break down either to 25 gig or 10 gig allows you to do the same with this, breaking down to 100 gig BiDi. So this transceiver will support 4 of 100 gig BiDi transceivers. So what does the future look like in terms of newer PMDs beyond what I just talked about, the 400 gig SR8 and the 400 gig BiDi SR4.2? And really, what we're looking at there and what we really want to focus on is that 800 gig solution that uses 100 gig per lane rather than 50 gig per lane like in the SR8. So you can envision if we have a single lambda solution that's cost effective, we can have 8 lanes of 100 gig, and it basically produces the same configuration in terms of the cable plant that a 400 gig SR8 solution would require. And the beauty of that is the roadmap from 400 to 800, there's no change in the cable plant. I wanted to flash this slide up because it caught my eye in the last couple of months, this preliminary solution from Gigalite. So this is a natural extension that I talked about a couple of slides back from the 400 gig SR8 solution to 800 gig with no change in the cable plant. So, you're servicing with SR8 400 gig, you're servicing 8 lanes of 50 gig, and in this solution you've got 8 lanes of 100 gig. And again, this hinges on that single lambda solution that we talked about at the start of the presentation. And you can see, we talk about 100 meters for the SR8 400 gig solution. They're chipping away at the reach. I think the IEEE is going to land. This is not an IEEE solution necessarily, the preliminary product information from a large module OEM. So they're being very conservative. I think that we're probably going to target about 50 meters with this 800 gig solution. So as an example, I'm going to use this chart here. This is actually taken from some Arista literature for their module lineup for 400G. And I really wanted to extend it beyond the SR8 to talk just a little bit about DR4 and differentiate between the application. We did talk about SR4.2 BiDi as a switch-to-switch. That's limited in reach, and the hyperscalers in particular are interested in DR4 because they're looking at 500 meters of reach there, and there's an XDR4 below that at 2 kilometers. So if you're a hyperscaler doing switch-to-switch, you've got some options there, low-cost, single-mode PMDs. The one thing I will note on this in terms of the SR8, and it's a little bit different for multimode solutions, is that the MPO connector, what they call the media device interface, the connector that interfaces with the transceiver, is an angled MPO 16. So it's a straight line of 16 fiber positions, 8 transmit, 8 receive, and it's an angled connector. So that's a little bit different than we've experienced with, say, 100 gig or 40 gig SR4 multimode solutions where we use a flat MPO connector. So what's new at the transceiver MDI? This is IEEE speak for the media device interface. This is the receptacle on the front of the modular transceiver that accepts the demountable interface, the fiber connector. What is different is the 16 fiber variant. So to support an SR8 transceiver, you have to have a 16 fiber MPO receptacle on the front. And I put as comparison here, on the left-hand side, our normal 8 fiber or 12 fiber or 8 position MDI, or 12 fiber, 12 position MDI on the left-hand side. So that would be for a DR4, an SR4, and so forth. And also for the BiDi 4.2 400G in comparison to the 16 fiber, which is on the right-hand side. One thing you will know is that the key is offset in the SR8 solution, the 16 fiber solution, so that they are strictly non-intermatable. So a 12 fiber, 8 fiber MPO connector will not mate into that 16 fiber receptacle of the SR8 and vice versa. So why would customers want to do 400G SR8 for their server pods switch to server? So it becomes a density issue, and you know, if it is a revenue generating data center, they want to maximize the amount of space, rack space, for revenue producing equipment. Typically fiber cable plant doesn't produce revenue, so density is a huge issue. So if I can consolidate 8 50 gig ports on one end on this high Radix switch to a single port, a 400G SR8, that's a good thing in terms of real estate, conserving real estate. The other key point is the power consumption. So 8 50 gig QSFP56 modules consume a lot more power than a single 400 gig SR8 module. So not only does it reduce the cable plant and simplify the cable plant like I'm pointing out here and increase the bandwidth, but the two main value propositions are operational expenses reduced and real estate, the footprint for the switch, is reduced. Although this slide is a little bit dated, you can see 2019 on it. This is happening very quickly, and I did recently find out that Broadcom is actually resampling a 200 gig NIC. These are in the market today. Hyperscalers are using 50 gig at the server. You can see the evolution there through 25 gig, 50 gig, 100 gig. It's happening very quickly, and it's driven by hyperscale. So here's an interesting slide that on the left-hand side shows the current switch to server application versus the future switch to server application. So top of rack switching, connecting to server NICs, 3 meters, copper. The future looks like decentralization of switching to end of row or somewhere else, depending on the reach of the solution, and we're seeing 20 to 30 meters. So this speaks to an end of row, high Radix, high speed 400, 800 gig switch at some point. Just an interesting snapshot of this is actually Microsoft's view of use cases today versus evolving into the future. And I did mention that they are using 50 gig today. The switch, in terms of the number of lanes times the lane rate, when we do that multiplication here, it's called the switch radix. And number of lanes means that I can physically break these things out. So if I can have a 50 gig switch, SR8 transceivers, I can actually physically break those out, those lanes, into 50 gig SR ports in NICs. And if we have 100 gig, same game. SR8, 100 gig at the server. So you can see the evolution from a 64-way 10 gig switch to, I think it's very close today, 256 lane times 100 gig. So let's make SR8 real in terms of a rack elevation. And I'm going to show a very high-level schematic here of server row. And you can see that I've deployed this 400 gig high radix middle of row switch. I could have multiples of that, and I've taken away the top of rack switch from each of the server cabinets. And so that server cabinet now is a good candidate for, let's say, rack and roll. And it's homogeneous with servers. So that leads to pre-configuration, you know, at the likes of like Dell, for example, in a very simple server build. And what I'm doing here is I've got that high radix switch. I'm taking that SR8 jumpering to a panel, and this is just one way to do it. I've got an overhead panel, patch panel, mounted to the pathway. And then from that center patch panel, middle of row, I'm going to trunk over to patch panels that are mounted to the pathways overhead of the server cabinets. And then in those patch panels, I will deploy breakout cassettes that provide the individual 50 gig LC connectivity on the front of the patch panel. And from there, what I will do is basically drop down to those server NIC cards with LC jumpers. So here is the basic cable plant, and it's a very high-level diagram. But what I'm showing here is a switch-to-switch SR8 to SR8 structured cabling channel that goes from a patch panel to a patch panel. In those patch panels, I have these 6-port MPO cassettes. I've got base 16 MPO trunk cables. So what that means is I've got cables that have maybe multiples of 16 fiber MPOs on each end that get plugged into the back of these panels. So one end to the other, this may go, you know, across the data center, switch to switch. And basically to connect the channel to the transceivers in the switch, I got 16 fiber jumpers, equipment jumpers, as I'm showing here. So that's the basic switch-to-switch use case in structured cabling for a SR8 channel. Even though that this will be the minority application, the real application is switch to server. So the first channel I want to talk about in terms of the switch to server breakout is probably not the preferred way to do it, but what I'm showing here and what's changed from the previous slide is in the bottom right there. Everything else is consistent from the left-hand switch, the 400 gig SR8 switch, and I'm working across, trunking over to that second 6-port MPO cassette. And what I'll do at that MPO panel is I'll have a breakout, and that breakout is a 16-fiber MPO that gets plugged into that panel. And then on the other end of that, I have 8 pairs of duplex LC. Each end of that will get plugged into a 50 gig server NIC card. Probably not the most efficient way to do it, because one of the concerns here is dealing with the respective lengths of each of these legs, and it really is more of a custom engineered solution in terms of staggered lengths and so forth. This is the same as the last slide, but again, I've changed up what's in the lower right from a harness breakout solution to collapsing that harness inside of an 8-to-1 breakout cassette. And this offers a lot of simplicity, and I'm calling it our preferred approach because it's a more logical, easier to manage, and less custom solution. So basically placing that 8-to-1 MPO breakout cassette that's fed by that 16-fiber trunk, and then parsing that out into 8 duplex adapters on the front of that cassette. And basically it's a matter of jumpering from the top of rack, the top of cabinet, down to the server NIC card with LC jumpers. I did touch earlier on this special breakout. Again, nothing's changed on the left-hand side, and we're breaking out on the right-hand side. And what we've got is the ability of that 400 gig transceiver to break out into 2 100 gig or 2 200 gig transceivers. And that may seem a little bit strange. Why would I use a 400 gig transceiver to break down into 2 100 gigs? It's kind of inefficient. But at least one vendor has a gearbox inside of that 400 gig transceiver that allows it to support 2 SR4 legacy transceivers, so the 100 gig transceivers, by shifting the line rate from 50 gig down to 25 gig. So 425s equals 100. And obviously the more natural and more efficient solution is to use a 200 gig SR4, so that one SR8 logically can support either 2 100 gig or 2 200 gig transceivers through this breakout cable that gets affixed to that 6-port MPO cassette. We've had a number of customers that want to deploy switch-to-switch with SR8, not a lot of links, but they want to recycle their existing base 12, so that's MPO 12 cable plant that they've used for a number of years. And they don't want to rip and replace with 16-fiber infrastructure, so panel to panel. So this is actually a patent image that I've taken, patent pending, for this little box that I'm showing here. On each end, instead of a straight patch panel, MPO patch panel or MPO fiber adapter panel, I've got this box that rewires 4 MPOs on the back that are 12 fiber to 3 MPO 16 fibers on the front. So the math, 4 times 12 equals 3 times 16. So it's basically a rewire for customers. If I put one of these on both ends of 12 fiber infrastructure, I can, with 4 MPO trunks, I can create 3 MPO 16 channels to support 3 400G SR8 channels switch to switch. And really quickly, here's more of a physical implementation of that. And what I've chosen here is a little bit higher density solution. So if I have 24 fiber MPOs that exist today, I can recycle those up using a higher density implementation. So in this case, I've got 4 24 fiber MPOs plugged into the back of these conversion cassettes. And with that, I'm creating 6 16 fiber MPOs on the front of each of these cassettes. So if I was to take that and plug those cassettes into 24 fiber MPO trunking systems, and I had 4 of those MPOs, I could create 6 SR8 channels that are 16 fiber and go switch to switch. Not for everyone, but for those few customers that have existing cable plant that want to repurpose it for switch to switch SR8, it's a pretty effective solution. We started the conversation with a statement about hyperscalers and MTDCs and edge data centers looking at new short reach technology and evaluating performance and cabling and so forth. And what I wanted to do here in a very short, simple way is to look at each of these protagonists, DR4, the 8-fiber single-mode solution, BiDi, which is coming, in SR8, which we've really talked about extensively here, and talk about cable plant cost and the module cost. And I'm going to talk in generalities. And it's really up to the listener to go out and build a bill of materials and cost these things out for themselves. But just in general, the SR8 cable plant is the most expensive because it uses multimode fiber. Multimode fiber more expensive than single mode fiber, and there's more of it. So it has twice the amount of fiber as a BiDi 400 gig channel would have because it's 16 fiber versus 8 fiber. And of course, the DR4 uses 8 single mode fibers. It's going to be roughly the least expensive of those cabling solutions. But the other side of that is the module itself. And unless you're a hyperscaler buying huge, huge volumes of these, the rule of thumb is 2 to 3x of the SR8. So DR4, roughly 2 to 3 times the SR8 cost. And the SR8 is going to be the least expensive module. It is the least expensive module currently. That multiplier may change if you're a hyperscaler. It might be something like between 1.4 to 2 times as much as the SR8. That's something you really have to evaluate. The BiDi is somewhere in the middle. And in talking to module manufacturers, it's expected to be between DR4 and SR8, probably closer to SR8 in terms of final cost. And that's my final slide, and without further ado, I'll pass it over to Stephen for Q&A.
Robert, thanks so much. And as you say, this is moving fast, and we've got a lot of questions from the community right up front. Let's take the first one. With all the benefits of single-mode fiber, why should or would someone still use multi-mode fiber? What's the point here, Robert?
Well, if you do the math on the solutions, I did mention that the single-mode solutions for DR4 have come down in price point. If you're a hyperscaler, those price points can be very low, but they're still much higher than the comparable multimode solutions in terms of the transceiver. And really, you really have to go out and generate a bill of materials of the cable plant plus the cost of the transceivers at the specified reach of the channel and do your own calculations. But in general, multimode transceivers are typically cheaper than single mode transceivers as a rule.
And you're right, it really does come down to price, as you just said, and that's another reason to really reach out to you and everybody at Panduit. Let's go to the second question. What is the business case for breaking out these 400 gig optics as you've described, because this is important?
I think the main business case, well, there's really 2 strong points in the business case and the value proposition for this. The first one is, if I have 50 gig NIC cards at the server and a 50 gig switch, I don't have all these independent transceivers. And what I've done is I've taken 8 of those transceivers on one end and consolidated them into a single transceiver that consumes less power, much less power than 8 50 gig transceivers, and also consumes less rack space. That's the second part of the value proposition.
If you don't mind, Robert, there's actually a question that pushes this to the next level, and that's how would one deploy those optics into an existing or an active server pod? Because this is a major issue going on now also.
Yeah, and you know, I think unfortunately there aren't good solutions to switch between plug-and-play fiber systems that are base 12 fiber. Versus base 16. So for the switch to server application, it's really greenfield, I would say. There's really not an opportunity to recycle existing cable plant because it is 16 fiber. You you can join together 2 8s. You can split out into 2 8s with 16 fibers. But in general, people today switch to server if they're using a fiber solution, and then switch to switch. It's base 12. It's 12 fibers. So, it's 16 fiber from the switch to the panel, 16 fiber trunking systems across to the server racks, breakout cassettes in the server racks, and LC cords. And it really has to be greenfield.
That's interesting, because now the next question that's come up directly to you is, why don't I just use direct connection? Because you've spoken about switch to server with an AOC, an active optical cable. And honestly, Robert, what's the advantages or disadvantages of this? Because a lot of folks are looking at, why can't I just do that direct connection?
Yeah, you can do a direct connection. Let's say it's 50 gig at the server. You can do a direct connection with an AOC and get the reach. You can do your 30 meters, much farther than copper twin acts. But the problem comes in consolidation of those solutions. Now, I will say that there are some SR8 AOC solutions on the market where you can consolidate into one transceiver 400 gig and have individual breakouts 50 gig AOC on the other end, but it's kind of ugly. And the cable is big, and if you have a failure, what do you do? If you have a failure of one of the legs, what do you do? Well, it's simple with structured cabling. You replace one transceiver. In this case, with an AOC, depending on the nature of the failure, you rip and replace the whole AOC, and that may impact, the other 7 ports that are connected.
Thank you very much. I mean, that was really direct. I appreciate that. And it says another reason why folks need to reach out to you. So let's get on to copper, because there's questions around that. At what point will higher speed copper solutions for switch server interconnect become a non-starter? At what point can we just say, forget it, I'm out, we no longer want to be looking at copper, Robert? You would know better than anybody.
Well, I think that at least the hyperscalers and some large multi-tenant data centers that are doing 50 gig are doing strictly AOC 50 gig, or starting to implement the 400 gig SR8 breakout to 50 gig. I think that the copper solution, it's limited by reach, and you don't get the flexibility that we talked about of taking the switches out of the server cabinets and consolidating them into a smaller footprint 400 gig switch.
Interesting. Let's take this final question then, Robert, and this is the last one because we're all running out of time, and I hope you can take this fast. But if I architect, as you just described, with 400 gig end-of-row switches, what's the expected life cycle of the cabling infrastructure when newer 800 gig or 1.6 terabit modules arrive? And can it be repurposed? I mean, this is going to be really critical here, is to have the capability of repurposing it again and again for new uses.
Yeah, I did touch on, kind of the roadmap beyond 50 gig at the server. 100 gig single lambda is going to enable an 800 gig SR8 solution. So it's not a rip and replace. It's change the modules, change the NIC card, change the module in the switch. There is some rumors about a 200 gig single lambda multimode solution, which would enable an 8-lane 1.6 tera. So I think this solution for switch to server has legs beyond 50 gig NICs. And I did show that, the 100 gig NIC is out there. They're pre-sampling 200 gig NICs. So I think it's the next logical progression.
Good to hear. Thank you, Robert. The next logical progression is what we need to know is coming. And with that, I'm actually run out of time. So to you and to everybody at Panduit, thank you for all you're doing.
Hey, thanks, Stephen. Really appreciate the opportunity to speak about this new application. And I will point the listeners to the hyperlinks that will be in the presentation and the Panduit resources from panduit.com that talk to these type of applications.
Incredible insight. Now it's time for your feedback. Please give this session an overall rating for the quality of the content, delivery, and user experience, and please remember to hit submit. We'd like to know what you're thinking. Thanks for joining us, and don't forget, next up at 5 p.m. GMT, we'll be hosting the closing panel with speakers from Equinix, Opti9, Juniper Networks, all expertly moderated by IDC, where we'll do a deep dive into the cloudification of the network and what level of intelligence and automation data center networks require. You can join that session right at the top of the hour using the link on your screen. And thanks so much for joining us. We'll see you then.